Well, got the OBS hooked up. I think I can get the dock set up, so let's see here. Might not have the chat hooked up. Okay, try it again there. I don't know if it's obvious here, but basically what I've got going here is two pieces of plate glass with some fiberglass cloth on it. Let me get a close up here. Let me get this camera so you can see what I'm doing. So I guess I'd put this under the category of a science fair project. So what I wanted to cover is the core material and just a brief history here. I remember it was probably 1976. Midwest had an airplane that was a styrofoam, and basically I think it was like expanded bead styrofoam. It never really took off because it was too heavy and it wasn't as good as the balsa wood stuff. It wasn't fuel proof, and there's a lot of issues with it, and that was before electrics. Fast forward to today where they have all the composite airplanes and also the foamies, they call them. So the foamies basically are back 1970 some technology, believe it or not, and it's nothing new. And one of the things they've done to incorporate the foamies into the mainstream is the electric. So if you're interested or you're involved in RC, you'll notice that the foamies are high performance. They're paired with LiPo batteries, outrunner motors, the ducted fan stuff. And the beauty of that is, for the manufacturer, is basically they don't have to spend any money on things they can't control, like balsa wood. The foam is available, unlimited supplies. It's the same density if you control your manufacturing process. So if you look at these airplanes at the Worlds, at the F3A, it's basically the same as the Yutsenkos, and they're all going to this composite technology where you have a core material, whether it be balsa wood, the Venicell foam, or whatever, but it's basically a sandwich core. Glass, and then the core. I worked at JT for a while, and I wasn't doing their composite work. I went into JT Composites to do their woodworking. And by doing that, I was able to ask a lot of questions and get a lot of help. And I sort of saw the high-end professional part of the process of composites. Now, I took some carbon fiber pieces out to Paul Walker at the Worlds, and I'll show you one of them. And what I was doing, I was taking pre-preg scraps, and I just take different layers. I had all different scenarios here. So I'd lay up these pieces, no autoclave, no vacuum bag. And these carbon fiber panels were just sandwiched between aluminum angles. And I clamp them together and then cook them in the oven, and it's pre-preg. So I take these to show them to Paul, and he grabs a hold of it and he looks at it. He's rolling around in his fingers. He says, "You're not going to like what I'm getting ready to tell you." And I knew exactly where he's going. And I sort of chuckled and I said, "Okay, you can tell me. I mean, you're not going to hurt my feelings." And he said, "It's too heavy. We've already been through this and ran the numbers, and this is heavy. This piece of carbon is super heavy." Okay, now you're looking at these guys out there that fly these gliders, and you're looking at people that are flying certain events, and they incorporate carbon. Tryon, the control line flyer, incorporated in his stunner. So the trick is, the problem is number one, the cost, what it takes to actually process it, and number two is the weight, or it would be the three things. So as I'm looking at all these airplanes, whether it's an Axioma, a Shark, or these pattern airplanes, they're all fiberglass. Now, RC basically can't transmit a signal through carbon, so that's a problem with RC people. So the transmitter's got to be outside of the carbon fuse or whatever. There's an issue there. Do I think that carbon can be applied to a stunner? And I do. It would be spread toe, it'd be super thin, it would be set up in a way that actually, you know, allows you to maintain that weight plus production. So this is where I'm at right now. So I'll get a close-up. This is a test sample right here, and what you're looking at is a piece of plate glass. And this, I got trouble with this lighting here. Okay, so this plate glass has got HTR 250, HT 386-99. HT 386-99 is 33% per hundredweight on an HTR 250. The dash 99 basically is an extended cure time, more open time. And it's the first time I've used it, and it worked out really well. What I've done is I laminated this last night on the glass. The glass has a release agent. It's Free Coat 700 NC, I think it is. Get my numbers right. Yeah, Free Coat 700 NC. 2 coats of Free Coat on the glass. HTR 250, HT 386-99, and the cloth here, it's probably 1.25 ounces. I've got 3/4 ounce, and this is 1 ounce, 0.2 or something. I don't know what it comes out to, but it's just a little bit heavier. Now, what I understand, the 3/4 and the 1 ounce, 0.2. It's not any thicker, but it just has more fiber in there. So if you can keep the resin content down, it's viable. And I think this is more of an RC cloth, and maybe the 3/4 ounce would be for a stab, or, you know, parts that are a little bit thinner. Okay, so what I'm going to do is I'm going to lay up these 2 pieces of plate glass with fiberglass cloth that's already been pre-cured. These glass plates went in the oven, and they went in there at 175 degrees for a couple hours. It was 150 for an hour, 175 for a couple hours. So this has been post-cured. And what I want to do is pour foam in between the two and let it cure. So this panel will give me an idea of what the weights are going to be. Let's see if I got close to that's 13 by 12.5. So what I'm going to try to do is lay this up to where when I trim it, I've got 1 square foot, 144 square inches. And that way I can weigh it and come up with an idea of what this is going to weigh. Now, this is 2-pound foam, okay? Don't ask me the manufacturer of this, because I got this out of a composite shop, and I bought this as a sample. 50-50, you know, by volume. You mix it up, and it probably within 3 or 4 minutes had this. So when he made this sample for me, he poured it in the cup, and I'm trying to visualize about how much was in this cup. It wasn't very much, and I'm going to try to duplicate that. I think this cup here, maybe just a little bit more, is what I'll need. These shim pieces are an 1/8 inch thick. Okay, so the reasoning behind all this, if you can imagine, a male and female mold coming together with a gap of an 1/8 inch or 3/32 ideally. I couldn't get the 3/32 sheet wax, they were out, so I went with 1/8 inch, and that's what these are. These are sort of simulating what the 1/8 inch sheet wax would be in a mold, which I'll cover in depth, the actual mold making, and I'll cover in depth the manufacturing of the part, good or bad, you know. So what you're seeing here for me is a first time deal. So um, I have no idea if this is going to work. I know the foam's going to expand, but as far as the properties, what this process does, if you can imagine the male and female mold, what this process does is get rid of the consumables. It gets rid of the vacuum bag, it gets rid of the breather cloth, the vacuum pump, everything. So basically you're making two parts laid up by hand with glass cloth and resin, letting it cure, bringing the mold halves together with that gap in it, pouring this foam, and you have a part. So if that makes any sense, that's what this is all about right here. So let me get the scale. I'm going to weigh these things and see how close to the same weight they are. I think I know by volume it's 1-to-1, but I'm not sure what kind of weight we're looking at. And the reason, I'll try to find the weight. I've got a way to weigh the foam by weight. I don't really have a good graduated cup. Let's see. I don't know. It's within a gram, so 461. Yeah, 461. Okay, this is a lot heavier, so I can't really go by weight. I can, but I don't know the ratio. So I'm going to go to a cup. I'm going to go to a cup that will actually give me a 1-to-1 ratio. I just didn't want to waste my measurement cup. So I just got one of these Sherwin-Williams cups. Let's see what kind of 2-4. Well, I'll tell you what. I'll pour this on the glass. I'll mix up 4 ounces, but I won't pour it all on the glass. I think I'll get in trouble by doing that. Let me see if I got a comment here. Oh, my granddaughter says hi. Hi, Murphy. So, I guess my granddaughter Murphy's going to watch the science fair project. So, I'll see you later, Murphy, when you get home. I love you. My fan club. So, I think, let me get some paper towel over here. Yeah, this will be interesting to see how this works. It's a science fair project. The other beauty of it is if you take a male and female mold and you apply the glass to each half, when they come together there's a gap, and that's where the foam fills. Number one, you get full adhesion. The foam will stick to almost anything, I believe. It's just unbelievably tenacious. The other thing you can do, let's just say up around the nose you need extra carbon, okay, or stiffeners of the wing root. So when you lay up this glass on the outside of your mold, well, it'll be the inside of your mold, but the outside of your part, you can also come in with more carbon or more cloth. So basically you can make it thicker with cloth, carbon, or whatever, but then you decrease the core size. Now if you want to compensate for that, you'd have to add more sheet wax when you make the male mold to compensate for that. So there's a lot of things you can vary. Once you get the mold, male and female, with the sheet wax, you can still add and subtract cloth and material inside of that sandwich core. So this is pretty much a quick process. It'll be interesting. Let's see here. Let me get the tell you what, it's not going to take that much. I'll go with 4 ounces, but I'm going to have a lot. I don't have any other cups that would be smaller increments. But I'll keep track of what's in the mold. The other thing with this core material, you can actually vary the density by what product you use. This one's a little sticky. These are just basically sample cups. It looks like the dark one would be the harder. It's a little bit more tenacious. Two. So this is where the race is on. So basically there's absolutely no extra time once you start mixing this. Well, we'll see what happens. You can see some air bubbles in there. I don't really think that's an issue. We'll keep track of what the leftover weighs, or the volume. So it's pushing out pretty good. Now the flat panel won't be very representative of the actual strength of the core material. You'll get a lot of strength in this core material by the shape also. So if you're doing a wing or a fuselage where it's got curves and high and low points, it adds rigidity to it. So what's going to happen too is this cup. Put this cup in the leftover in the cup is actually going to start coming out. I do know this stuff is sort of sensitive to temperature and moisture. And I think the properties of the foam might be a little bit different because of the narrow gap that the foam has to expand into. And that would also change the density. I mean, the more pressure you put this foam under. And one of the things I'm pretty much figuring out right now is the amount of pressure it's taken to hold this foam down. It's wanting to push up. So that sort of tells me that when it comes time to make the mold, it's got to be rigid enough to hold this foam down. So what I'm doing here is keeping the plate glass pushed down to the shim stock. To maintain my core at an 1/8 inch. Also, what is happening too, the foam is pushing my shim stock out a little bit here, which is okay. I sort of figured that. This might not be an exact perfect 1/8 inch, but it'll be close enough for testing purposes. So if I had to do this again, I would probably clamp it, but I can get a pretty good feel of how much pressure it's putting out. So by moving this around, I've actually probably introduced some air bubbles underneath it, but it's still all right. Keep my shims in there. The other thing that happens on this foam, it gets a skin on it. So I don't think the pressure was too great. I had moderate pressure on it. The main thing is when I design the two mold halves that it has plenty of room to escape. It'll be interesting to see that free coat, how well it releases the foam. Some of the foam got on my gloves on that back side of this glass. So the upward pressure on the glass plates is pretty much finished at this point. There might be a little creep. That was my other concern. How much pressure continues once the foam is fully expanding. I guess you'd call it creep. So we had probably, I'm trying to remember what was left in the cup after I poured it out. I probably poured, I don't know, maybe close to half of it or a little bit more or less. So I had 4 ounces, probably only needed obviously 2. And I knew not to pour the whole thing in there. I knew that would be a disaster. Yeah, when you're stirring this stuff up, you can almost see it instantaneously start to expand. And when it really starts to move, it's like you got to get it out of the cup really quick. So I think you're probably looking at maybe a couple hours. The other thing that was mentioned to me, Dave Matney, I think is his first name, Dave. He talked about just scrimming this fiberglass on the mold, not even using epoxy on the inside, and letting the foam actually bond to it. But I'm not sure about that process. I know on the outside I'd want the epoxy glass. So going forward, if I had to do this experiment again, I'd probably glue these shims down to the glass so they wouldn't move. And I'd actually probably put some clamps around it. But this will give me the information I need. I'll tell you what, this stuff is unbelievably sticky. It's like old clothes and gloves. It's not an option. Okay, we'll let that cook off or whatever it needs to do. One of the things I wanted to do, I might as well do it now while I'm out here with the composite stuff, is undo this mold. I made a couple more gear. Let me go over here and grab those. These landing gear. Let's get some stuff out of the way. It's always fun opening these up. What I try to do when I make these parts is stay on one process, which would be layup, and then probably later today I'll go into the second part of the process where I deflash everything. So it's a pretty good day out there, so it's a good day to take the dusty stuff out in the outside. And really, I mean, if you wanted to make a hollow structure like a carbon fiber gear, you could probably use the same foam. So the foam you saw me use over there on that experiment was is what they were using on a steering wheel. There's a shop that I go into and buy raw materials, you know, a yard of this, yard of that, and they're the one that sold me the foam. So they were actually using it on a manufacturing process for steering wheels. Somehow they had a mold where they were doing the carbon outlay outside of the mold, or outside of the wheel, and then they core it with the foam. I'm Not sure of the process, how it'll work. There's that one. I like to do it on the floor. That way, you know, something happens. I mean, if you drop it, you're not going to hurt anything.